Hi, everyone. Thank you so much for joining us today. A warm welcome to you all. We have registered participants from the age of 3 to 83 today. So it's wonderful to see that so many of you across age groups are interested in learning more about nature and sounds of nature. My name is Shruti, and I'm a part of the Early Bird team at Nature Conservation Foundation. And if you're joining us for the first time, let me share a bit about what we do. At Early Bird, we work on connecting young people with nature through birds. And to do this, we create lots of bird-themed resources, colorful booklets, fun games, online resources, and lots of other resources which you can use to learn and also teach about birds. In addition, we also host sessions like this one, where we come together to explore the wonderful world of birds and other creatures. In today's session, we will explore the fascinating world of bioacoustics. That's the sounds of nature. For this session, we have Rithika Fernandes from the Roundglass Sustain team. Roundglass Sustain is a not-for-profit initiative dedicated to telling powerful stories about India's natural world to inspire wonder, foster awareness, and drive conservation. Through amazing films, photography, and writing, they are documenting the country's rich biodiversity and creating a free digital encyclopedia of species and habitats. Check out their website for some stunning and interesting content. At Roundglass Sustain, Ritika drives outreach and impact. She's an ecologist who has worked in the sector of climate change and urban biodiversity. She loves books, trees, and birds. Ritika, thank you so much for joining us today. Over to you.
Thank you. Thank you, Shruti, for that really comprehensive overview. And thank you for introducing me so that don't have to do it myself. Hi, everyone. Thank you for spending your Sunday morning with me to answer the question why scientists are listening to nature. Before I take you through to the whats, the whys, the hows, the wheres of bioacoustics, I would really like to introduce you to my organization, Roundglass Sustain. As Shruti mentioned, we are a not-for-profit organization. We tell stories about India's natural world, and we do this to create awareness as well as support conservation. We tell stories of habitats, of species, communities, and we do this through films, through infographics and narrative texts, as well as some of these beautiful pictures that you can see on my screen. Why do we tell stories? Well, we actually believe that stories do something really powerful. They make us curious, they make us feel wonder, and most importantly, they make us care. So I think the secret is that when you care enough, you step up to advocate for and protect what you can. In this case, it's nature. And so I suppose the question on all of our minds today is whether I think we've all wondered what animals are saying when they're chirping and croaking, they sing and they squeak and they howl. Do you think that they're chatting? Maybe they're warning each other, saying, back off, or they're saying, honey, what do we want to get for dinner tonight? And these are questions that we had at Roundglass Sustain. So we decided to do what curious people do, and we call the scientists. So we reached out to people who study animals, how they communicate, and believe it or not, animals have languages, they have accents, they have dialects and rules just like us, and it's amazing. So today, my aim is that I'm going to show you through our Roundglass films how scientists eavesdrop on nature. There are 5 films I've got lined up for you that will take us from the basics of bioacoustics all the way to the fascinating details of how animals communicate. And we'll hear from frogs, we'll hear from underwater animals, we'll hear from birds because this is an early bird session. And I hope that by the end of it, we all begin to understand and hear nature in a very different way. Just some basic housekeeping. Not housekeeping, but basics about bioacoustics. Bio is life. Acoustics is sound. So simply put, bioacoustics is studying life through sound. But why do you think scientists are interested in studying sound? Well, Sound is actually really powerful. So without being able to see an animal, when you hear it, you can potentially identify what animal is talking. Has anyone played the game Marco Polo, or has anyone heard of the game Marco Polo? Yeah. Well, I know the Indian version. We used to play something called Blind Man's Bluff, where we tied our eyes were closed because we tied a piece of cloth around it, and everyone would make noises, and you had to try and find the person making the noise. In Marco Polo, someone goes Marco, and the other person goes Polo, and you try to find that person just by their voice. And so I think this is what scientists do when they're studying bioacoustics. Of course, it's far more complex, but simply put, Superman, I thought, had a really cool power of X-ray vision. And now I know that it's probably, if he had supersonic hearing, that was far, far more powerful. Because sound travels much further than sight. Scientists can hear animals that they might have never seen, animals that are hidden away in trees or underwater, animals that are active only at night. And I guess the question then is, how do they do it? They put these little waterproof recorders in many places, across forests, under the water, in jungles, and they can capture these equipment can capture sound for weeks at a time. The recorders are like these super powered ears that never get tired. And I think all of you know that the human our hearing is limited within the frequency of 20 hertz to 20,000 hertz. So we can't hear anything below, but we can't hear anything above that sound range. But bats, for example, who communicate on a much higher pitch, you have bioacoustic recorders that can actually pick up that sound. Elephants that use infrasonic rumbles to talk to each other across distances can be picked up again by a special kind of bioacoustic recorder. And our website has some really, really cool films and stories about this. So if you're interested, please go check it out. Okay, time for the first film. I'm going to play it for you. I hope you can see it. Give me 2 seconds.
As the night guard retreats, the forest goes quiet for a few moments. Then, the first rays of light filter through, and it erupts into a resounding dawn chorus. But there is so much more to these sounds than what meets the ear. Birds and animals make different sounds for different reasons. To attract a mate, to communicate, or to even set off an alarm. But why are scientists eavesdropping? Let us explain. Scientists have been trying to understand this wild orchestra for decades, resulting in the field of bioacoustics. Researchers record sounds in nature, from bird calls to rainfall, to study how creatures communicate with each other and interact with their environment. Analyzing these recordings from dense forests and the depths of oceans can give us answers on the species that are present in a habitat, how healthy their population is, and even how they respond to habitat destruction or human disturbance. Their special tool? The spectrogram. The spectrogram is a visual depiction of sounds in a landscape. All these squiggly lines are the vocalizations of multiple species of birds, insects, and mammals. Understanding these vocalizations has led to astonishing discoveries. Researchers have been able to record the song of blue whales from waters near Kerala, confirming their presence along the Indian coast. Decode a complex communication system among the cacophonous babblers in Punjab, and even analyze the health of forests in the Western Ghats. To an untrained eye, a protected forest and the one that has seen human interference and destruction may both look lush and green. Recordings from the area show otherwise. The difference is stark and telling of the health of an ecosystem. Scientists feel that the field of bioacoustics can help aid conservation, as it allows us to study the effect of external man-made noises like horns, traffic, or even a bulldozer on forest biodiversity. The possibilities are endless. So the next time you hear a frog croaking in your backyard, listen in.
Okay. First film. Let me go back to my PowerPoint. So now that you know some of the reasons why scientists study bioacoustics and what it's used for, I would like to move on to listening underwater. Now, the field of marine bioacoustics is extremely fascinating because, in case you didn't know, sound carries so much better in water than it does in air. It actually travels 4 times faster. And so scientists decided that they wanted to listen into what was happening underwater. Why? Because marine animals like whales and dolphins, they can communicate over really long distances using sound. For example, a humpback whale's song can travel across an entire ocean. And a blue whale, you can hear it 1,000 miles away. It's like whispering from Delhi, and you hear the whisper in Mumbai. And scientists use special microphones, recording devices called hydrophones to record these deep sea sounds. And they can do it in shallow areas like coral reefs, where the diversity of species is in plenty. But you can even go to some of the deepest parts of the oceans that humans cannot access. I wonder if everybody here knows what the deepest part in the ocean is. It's the Mariana Trench, and it is so deep that if you took Mount Everest and you dropped it into the ocean, the peak of Mount Everest would still be 2 kilometers underwater. That's how deep it is. But I guess in these kinds of places, if we use sound recorders, we'd probably be able to explore parts of the ocean that we could never have with cameras and divers. So that's the fascinating part about listening underwater. And in my next film, The Sound of Water, in the next film you'll see, we'll hear from 3 very cool scientists, Isha Bopardikar, Divya Panikar, and Mayuk De, who will show us what they're listening to in their research and what they're doing under the sea. So just as soon as it loads.
The end of World War II saw the release of wartime equipment and declassification. classified data. This included devices and data from anti-submarine warfare, which recorded ocean sounds for echolocation and enemy presence detection. But there was a strange disturbance in these recordings. Snapping shrimp, spawning fishes, and echolocating dolphins. Scientists suddenly realized that the underwater was a very noisy space, and soon would start listening to this noise for research. But how would this change what we knew about our natural world? And why are we still listening to underwater sounds today? The year was 2014. India's marine product export had reached an all-time high at 10 million tons, worth Rs 33,000 crore. Isha Bapardikar had been helping friends conduct surveys with fishermen in Sindhudurg, but she was filled with a curiosity about how dolphins sound underwater, until she recorded the sounds herself.
And I was like, just curiosity, I think, of how these animals would sound underwater. And then I actually got a chance to listen to them because a friend of ours had a hydrophone that she lent us.
At the Lakshadweep coast, Divya Panikar, who was sighting dolphins, had a similar interest.
We found blue whale calls in the data set, and which confirmed that there were live blue whales using the area and singing in the area. And we found that most of the songs were during April and May. And we also saw the North Indian Ocean blue whale song, pygmy blue whale songs.
Both turned to bioacoustic monitoring to know more, and when they listened to the sounds, the ocean threw back a plethora of noisy information.
In this area, we were hearing fish choruses, snapping shrimp choruses.
I thought, oh, now that we have these sounds, what should we do with it? We need to learn how to analyze them.
Soon, they were not just detecting species.
I look at aspects of habitat use and distribution of dolphins as well as whales. For my PhD, I used bioacoustics to try and understand whale and dolphin distributions in Lakshadweep.
My current study is using acoustics to understand animal densities, estimate animal densities, occurrence patterns, and habitat use for two species. That's the humpback dolphin and the finless porpoise.
As marine biologists, Isha and Divya analyze acoustic data to study behavioral patterns in marine species. This is possible because sound travels faster and further in water than in air. There's also the fact that underwater species choose to communicate in their natural habitat.
More than 90% of their lives happens below the water surface. We only get a little glimpse into their lives when they come at the surface. So they constantly produce sounds. Like they use sounds to interact with each other. They use sounds to navigate. They use sounds for finding food, for prey detection. So they use acoustics as primary sensory modality. They use it to interact with each other and their environment. And you can actually use the sounds that they produce to understand more about their life.
Recording devices called hydrophones are dropped in water to record lower and higher frequency sounds. Hydrophones record this data for days to years sometimes. And then this data is analyzed through spectrograms to learn about a species and its vocalizations, with some hiccups in place.
You put in a very shiny, like black instrument or whatever, and it comes out like multicolored, full of stuff. And you were spending hours trying to get it out so that you can deploy the same instrument later.
But animal sounds aren't the only thing one hears underwater.
And then mostly what I hear is the boat. I've recorded boat noise a lot of times, and it does overlap with a lot of the dolphin frequency.
Anthrophonic sounds, or human sounds, increase as ships and boats enter these waters. In traffic-dense ecosystems like rivers, it becomes important to listen for the impact these sounds might have on species. To understand this impact, Mayuk has been listening to river dolphins in the floodplains of the Ganga River in Bihar.
If you have lots of traffic, then in a loud place, in a crowded place, you need to shout. A similar analogy. We would expect dolphins to compensate by increasing their loudness, how loud they speak. It's probably changing their frequencies, how long they call. All of these ways. But what we found was actually the opposite. As you had more consistent vessels moving over the seas, water, you've actually seen them not vocalize as much, compared to their baseline levels.
Since rivers are low visibility ecosystems, river dolphins evolved to have low vision and excellent echolocation, relying entirely on sound. But anthrophony impacts this efficiency.
If you speak loudly for 2 minutes, you start panting. The same applies to them. So in these really chronic situations, dolphins don't really echolocate. And that can have potential consequences in terms of how much they feed, how do they communicate, where do they navigate. And because they need sound to navigate, and you've got these shallow river and vessels flying, chances of vessel collision and mortality probably increase.
Anyone who lives near a train track or an airport will know what sound can actually do in terms of having a constant noise being introduced into an ecosystem.
So bioacoustic data can indicate the impact of human sounds on aquatic soundscapes. But it is also telling us about something that impacts both human and marine life: climate change. Rising sea levels, warmer waters, erratic weather patterns all affect the geoform of underwater ecosystems.
It has two ways that climate change can impact, right? Like one is where it actually impacts the habitat, right? Leads to a low number of animals or a low number of a particular species. You could also think of it in a pathway where it's directly impacting the acoustics itself. It may not directly impact the numbers immediately, but it impacts behavioral responses.
But the difficulty has been in getting initial data to understand the extent and magnitude of these changes.
Could be affecting them quite a bit. It's just that we don't have that information. We don't even have baseline information on the acoustic behavior of this animal. We don't know a lot of details, fine scale details. So there's a lot to do, and it's barely the surface gets scratched.
Fish are completely understudied. So, for example, we had river dolphins in the 1970s. We had this person, Dr. Pilleri, who had taken dolphins from Pakistan to Switzerland, I suppose, and kept them in tanks for 2 years, 3 dolphins. And that is where we have most of our information of their feeding. What do these clinics mean? Even if we record sounds in the river system or marine systems, often we do not know what behavior it relates to. And that is something we can only do if we observe them.
So while we have heard a lot of the ocean since World War II, to understand and save our oceans, we need to keep tuning in.
Okay, so some really heavy stuff there. Obviously, we don't know enough. And from what we hear, it can be really concerning that anthrophony is increasing and some of these animals just can't hear themselves. But maybe to lighten the mood, I will tell you something that I just learned, that, we've heard the dolphins in the clips, right? So did you know that they have signature whistles that they make? So these whistles act like names. They're able to call other dolphins. So maybe a dolphin is going, okay, that's a very poor whistle, but a really high whistle, a high-pitched whistle, and maybe that dolphin saying Venkatesh, and Venkatesh knows that that dolphin is calling it. So that's a really cool fact, I think, and it probably just takes us away from all the doom and gloom that we just heard. All right, moving on to our feathered friends. How many of you have seen these birds? These little gray, very, very grumpy looking, noisy birds. They come to our balconies, they come to our parks. Have you guys heard of the jungle babblers? Show of hands. No? Yeah, I don't see any hands up. Okay, I do see some hands up. Okay, great. Yeah, they're very, very common birds, and they hang around in groups. And people say, so noisy, but the science tells us something extremely exciting, that the jungle babblers babble is very complex communication. They have different calls to find food, to spot danger. They have calls like a roll call. They're keeping track of who's missing. They call the group together. And scientists in ISA Mohali actually did a study on them. It would have just remained in the realm of research papers until we met Dr. Manjari Jain and we turned it into a short film for you all to have a look at. So I'm going to play that film for you. And hopefully we can decode what these babblers are babbling about.
The last study on the jungle babblers was done in the 1970s by someone called Tony Gaston, who came all the way from Oxford to do his PhD in India in Delhi Ridge. Jungle babbler, I think the name itself is a misnomer in every possible way. It is not found in the jungles. It is found mostly near human habitats. And I know now that they don't babble. There is meaning to their calls. If you go close to them, even though they are adapted to the presence of humans, they'll start getting very anxious, for the lack of a better neutral word. They will flit their tails up and down, hop around on the branch, and they'll produce a lot of vocalizations. But then if you just let them be and then they go back to their foraging, you will see a group of individuals, a bunch of individuals will be foraging on the ground. You will see one that has occupied an elevated post. So it goes up onto the branch of a tree or a lamp post, whatever, some elevation, and it looks out and it produces a very soft vocalization. So it was almost as if it was watching out for the others that are foraging. And that was really the most fascinating behavior that really got me interested in these birds. What we know from our work is that the birds produce these 15 different kinds of calls in different behavioral contexts, and by studying their behavior and doing some manipulative experiments using playback, we now know what these calls mean, if you like, and in what context these calls are produced. For instance, they forage in a group, but as the group foraging in one place, now they need to move from one place to the other, they need to move together. So how do they coordinate the group movement? So the bird starts to produce a certain kind of a call. And then they produce that call, which is what we call as a flight call. So they start producing this call and then they fly. So it's almost something is going on where there is a group level decision making that is going on. Then they have something which is called as a contact call. So while they are moving, if one is left behind and the group moves, then it produces a certain kind of call, and this is a very common call. Then the group members respond back, and they kind of duet for a bit and localize where the left behind member would be, and they come back to fetch it, and then they go back together. So social animals who live in stable social groups, we expect them to have a large repertoire size because they need to coordinate group level interactions. So they need to coordinate many different activities and not just produce one song to attract the female or to defend the territory. They have many different tasks, if you like. They're really such a misunderstood species. The first thing that when you tell anybody about jungle babblers, like, oh, the angry birds. And their aggressive behavior is, so when we looked at the time budget, what proportion of their time they spent in aggression versus, social behavior like playing or grooming each other. And we find that their aggression is less than 1% of their time budget. And so I really feel that, someone really needs to rescue the babblers from the very bad reputation they have got about, being the angry birds. Maybe anxious birds, but certainly not angry birds.
Okay. So now we'll know a little bit more about these birds. And let me tell you, you've probably known them as the Seven Sisters, or I think they're also called Saath Bhai. But groups of these birds can be anywhere between 3 and 20. And, we've heard about how complex their communication system is. It's like trying to organize your family group to do anything at the same time, but they're really efficient at it, aren't they? When I was in school, I was class rep. So I was the person who was on the lookout for the teachers. And every time we would see a teacher, I would see a teacher coming, I'd make sure, to tell the rest of the class to be quiet. Jungle babblers are also very cooperative. So there may be one pair amongst them that is breeding and the others help out. So they're literally the kind of birds that embody that phrase that says it takes a village to raise a child. So very, very cool birds. Now moving on to frogs. We've seen birds, we've gone underwater, but frogs are really interesting to record the sounds of, and scientists love studying them because frog calls can be loud, they are distinctive, and they're very different for each species. No two frog species have the same calls. When I was younger, my mom used to make up stories about animals that lived around us. And so we had Freddy the frog and Teddy the toad. Now, I never knew the difference between the two of them, but I think she could clue in on their vocalizations, because the common Asian toad, which is common in Hyderabad, goes like a croak, 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 croak. Really, really terrible imitation. And we have skittering frogs, which I cannot imitate because they sound like they're making a succession of very high-pitched farts. But I think my mom knew, which is why she knew who was Teddy and who was Freddy. So scientists can listen to frogs by just, they can identify them just by listening, even in the dark. And they use special audio equipment to record the calls and to analyze their patterns. Frogs sing for a number of reasons. They mostly sing to attract mates, but they can also, defend their territories, warn of danger, express distress. And some new studies have been finding that frogs can change the pitch of their calls depending on temperature. And that's really important to study because climate change is impacting temperature around the world. Temperatures are we're seeing higher temperatures. And when a frog begins to call at a higher pitch, it probably might not be so easy for other frogs to hear it. So this is another reason why scientists are really interested in finding out what frog song tells us. So this next film that I'm going to show you, Dr. Sheshadri is going to show us how frogs have rhythm, that they have timing, and even competition, like the Battle of the Bands.
just like how birds sing, each species of frog or a toad has its own kind of call. Frog calls basically are a signal from a source to a receiver. Typically, the frog calls you hear are a signal to the female, telling something about the male. And in endurance, the female tends to choose males based on the quality of the call. And you'll have to remember that there is no one-to-one signaling that's going on. In a given area, there are multiple males trying to attract females. If there is a male that's calling at a higher pitch for the longest part of the night, then the female maybe uses it as a measure to say, despite all the risk, this male is still continuing. Maybe it's got good genes. One of the interesting frogs that you can hear when you go to places like Agumbe, the call is like a water droplet falling into a bucket. It kind of goes like tuck. And these frogs are half the size of my thumb. It starts with the tick, 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 tick. It goes on for like 40 or 45 such notes. We don't know what the trr and the tick mean for the individuals out there. The male frogs squeeze inside bamboo and they start calling from inside of bamboo. One thing that we measured was we looked at how many times they make this call per minute. And they seem to produce, I think, 11 calls per minute. And they call from 6 p.m. to like 4 a.m., 5 a.m. They continuously call. And it takes an incredible amount of energy for a frog that's half the size of my thumb to make such calls. With frogs, what happens is they have a closed system where they take in air, they close their nostrils, and they pump the air from the abdomen into what is called a vocal sac, which is usually at the base of the throat. Essentially, what the vocal sac does is it acts like a reverberation chamber. It's like the base of a veena, for example. It amplifies the sound, and that's one way how frogs are able to be so loud. Habitat loss, such as, say, building a road in there, it would open up parts of the forest and there would be other noise that comes in. And this will have implications of how the communication works between frogs. Studies have shown that the male frogs alter their frequency or they start calling at different times of the night. Calling consumes energy and it's making the frog vulnerable.
Okay. Now we're going to go back to birds. And I have a question for you all. Is there anybody here who still thinks that bird brain is an insult? Well, it's not really an insult because the thing is that bird brains are highly complex and they're also very, very efficient. In that tiny little head, there's a lot more neurons that are packed in there than in mammals. In fact, despite their small sizes, species like crows, like parrots, they exhibit remarkable primate-like intelligence. They can use tools, make tools, they can plan, and they have memory skills. So today, what I want to do is to introduce you to one of the smartest birds, the Greater Racket-tailed Drongo. Racket-tailed Drongos are really interesting because they can mimic other species, not just other birds, but they can mimic cats and dogs and ringtones. It's like they have a sort of built-in sound system that's hidden away inside their brains. The Racket-tailed Drongos are known to be kleptoparasites, and that's just a fancy word to say that they're thieves. They steal food from other birds, and they do this by mimicking alarm calls. So when a bird calls an alarm, it means that there's a predator close by, and so it scares away the other birds, and the drongos just swoop in and steal their food. And drongos are so smart that they can use different tricks on different birds, and they can even learn from, if this trick is not working, let me try something else. So that, that just shows us how intelligent these birds are actually are. They learn from their mistakes. And now in the film that I'm going to show you, scientist Samira Agnihotri, I think she is a PhD. She uses bioacoustic analysis to study how these birds learn and produce different sounds. And, this kind of helps us understand not just what animals say, but also how they think and solve problems. So let me load that film for you.
An eagle, it was calling like a woodpecker, it was calling like a babbler, and we were mesmerized. At that time, I was accompanied by M.R. Madegoda, and he said that you should do your PhD on this bird, because it's doing its PhD on all the other birds. I'm Samira Agnihotri. I'm trained as an ecologist, and I have followed Racket-tailed Drongos for most of my adult life. Very often you hear Racket-tailed Drongos before you see them. Really veteran bird watchers have been fooled into thinking that there are 10 birds in this patch and I should go and see them, and once they go closer, there's only one Racket-tailed Drongo doing their thing. It's very vocal, so you will hear it before you see it. And when you see it, you will fall in love with it even more. Glossy, iridescent black bird with jaunty crest and beautiful long tail feathers. Salim Ali had written about this. He described it as, it looks like two bees following a blackbird because of the, I found broadly that it mimicked in 3 situations. One was during the breeding season, as I said, when it was defending its territory and looking for mates. It also makes a lot of mimicry when it's a part of what are called mixed species flocks or mixed hunting parties, which are these aggregations or dynamic associations of different species of birds feeding together, moving together through the forest. And the third time I saw a lot of mimicry was when they were defending their nests. The mimicry that they do around these flocks is for 2 reasons. One, to locate them. So if I'm a Racket-tailed Drongo and I'm hungry and I want to forage with these flocks, maybe jungle babblers, because they look for these insects, right? And that disturbs a lot of insects, the leaf throwing that babblers do. So when Racket-tailed Drongos are jungle babblers, he or she will make the contact calls just like the babblers. Babblers do this contact call, which is like, I'm here, I'm here, I'm here, I'm here. Racket-tailed Drongo hangs out with them and says, I'm here, I'm here, I'm here. Similarly, woodpeckers. Drongos love to hang out with woodpeckers, and on that occasion, the Racket-tailed Drongo mimicked the woodpecker's call almost 20 times until it heard a woodpecker call in response somewhere, and then it flew in that direction. There is one more element to this multi-species association, and that is sentinel behavior, or watching out for danger. Drongos, in many languages, they are referred to as kotwal or policemen in some way, because they are so fearless and they attack birds and things that are much larger than themselves. And so that is also a reason why, if I was a babbler or any other bird, I would want a drongo around, even if sometimes they take more food than they should. To tie it all up, the mimicry is used probably to attract mates and influence mating decisions and defend territories, but they also use mimicry to talk to other species and hang out with them. Bird brain, which is used as an insult, is actually the opposite. I think birds are much more intelligent and complex than we give them credit for, and then we know. In one of the talks that I gave about my work at a school, a small third standard boy, I asked them, why do you think the drongo is mimic? And he said, it's simple, to make friends with the birds. And I think, the scientific theory aside, I think I must accept that as an explanation.
Okay. So I think that brings us to the end of my talk. And I hope that now you understand a little bit more about why bioacoustics matters, because bioacoustics helps us understand behavior. We learn so much more about the ecosystems we're in. And nature is full of a lot of conversations. We're only just beginning to understand them. So the next time you step out, I hope you listen carefully. Now, I've got a little quiz prepared to test whether you were all listening to me. So I'm going to ask Shruti how long I should leave between slides. Give me a second. I'm just trying to present this. This is a really, really simple quiz that our team has put together. And Shruti, you'll have to let me know when to move to the answer slide. Okay?
Yes.
Really see what's happening.
Yeah, ready.
Okay. Is everybody ready? Do we have any housekeeping rules for people, Shruti, about the polls?
So a poll will just pop up on your screen and you have to choose the right answer. We will give you just 5 to 10 seconds. So think quickly and answer the question.
Okay. Are we ready?
Yes. Okay, around 13 people have answered so far. We'll give another 5 seconds.
Yep. All right, moving to the answer.
Yeah, let's see the poll results. Can you see the poll results, Ritika?
Yep. Well, oh, not bad. We had equal Indian giant squirrel and equal cicada, but it is the Indian giant squirrel. So good job to those of you who got this right. Okay, next question.
The answers are still coming in.
Mm-hmm.
Okay, I'll end the poll now.
Okay, I'm going to the answer. Oh, good job. Whoever said water drop frog was right. And this is 79% of you. Well done. Okay, on to the next question. "45% says grey langur. We've got 30% that says Indian bustard, and Gangetic dolphin is at 25. So everyone's a little conflicted about this one. The answer is, ta-da, the great Indian bustard. Well done to those of you who guessed it. Next question. Oh, yeah, that didn't work out as well. I gave you all the answer. Should we just move on?
Yeah, we can move to the next one.
Yeah. Okay, let's go to the next one. Oh, good job. I think most of you got this answer correct. It is, in fact, the hula given. Yes. Okay. Next question. Okay, so we have a few conflicts here, but overwhelmingly Forest Crane, and you're right, Cyrus Crane. Well done to those of you who guessed it. Next question. I think there's a little spelling error. Should be rapidly. Could also be rapidly.
Oh, sorry for that. Yeah.
No, that was us. Okay. Do you want to hear the sound again, or shall we close the poll?
Yeah, we can listen to it once more.
Okay, hang on a second. Let me not give away the answer. Hang on.
Okay, I'll end the poll now.
Yeah, wow. You guys are spot on. Indian nitre. Very well done. And next question. Okay, a little bit of conflict here. The correct answer is Grey Langur. Congrats to those of you who figured it out. We're almost done. This one's easy. We just heard. We watched the video. So I think you should all get this. Oh, good job, everyone. You were listening to me. That's awesome. It is the jungle babbler. Well done. And finally, last question. This one's easy too. Oh, good job. To the 96%, I thought 100% of you would get it. The answer is Greater Racket-tailed Drongo. Well done to you all. Thank you. That concludes our session, as long as I stop the Drongo from calling. Yeah.
Great. Thank you so much, Rithika, for this very lively and fun session. I really enjoyed listening to the variety of sounds from nature, what they mean. And sounds travel faster in water. I didn't know that. How cool is that?
Yeah. Yeah.
And-
Lots of tidbits that I've learned about more as well.
Oh,
So,
yeah.
yeah. Thank you for having me, Shruti.